So, you've got a metrology-grade 3D scanner now. You scan a part, but the numbers still don't match the CAD file. What went wrong? Here is the truth. In industrial metrology, accuracy isn't just a number you buy in a box. It is a condition you have to actively maintain. When we measure at microns level, we're fighting against physics. Hi everyone, it's River here. On Metrology TechTalk, we're going to look at the 4 main factors that affect your data accuracy: the calibration, the environment, your scan path, and advanced tools like photogrammetry. We will break them down in this series, and today we're tackling the first 2. Let's start with calibration. Think of your scanner like a high-end guitar. You wouldn't play a concert without tuning it first, right? Shipping, temperature changes, or just everyday use on a messy shop floor can cause microshifts inside your optical system. Calibrating your scanner is an important step, both when you first unbox it and on a regular basis after that. Using a certified artifact like a calibration board brings it back to the baseline traceability. It only takes you several minutes, but saves you hours chasing bad data. Next, let's talk about the variables in your scanning environment and how to control them. The first factor that many people overlook is the temperature. We all know that materials expand or contract with temperature shifts, but it's not just the scanned part that changes. It's the internal components inside your scanner too. That's why keeping your scanner in a temperature-controlled environment is critical. And more importantly, warm up your scanner. Let the internal components reach an equilibrium thermal state before taking measurements. Alright, so the room is in a stable temperature. But what if the floor is shaking? Vibration is also one of the biggest enemies. A 3D scanner is essentially a highly advanced camera system. Just like taking photos on your phone with shaky hands, the images will be blurry. During a 3D scan, heavy vibrations will also blur the raw 2D frames. As a result, the software generates noisy and lower quality data. To avoid this, try to isolate your setup on a vibration-free workbench. If that is not possible, use reference markers so the scanner can dynamically track the part even if there's movement. To sum it up, calibrate regularly and control the environment variables to get the accuracy you pay for. But what if the environment is perfect, your scanner is calibrated, and you still get bad data? That's when we have to look at the operator. Next time, we will talk about your scan path, how your movement, angle, and tracking affect the final measurement results. I'm River. Make sure to follow Shiny 3D Metrology on LinkedIn so you don't miss it. See you next time.